Okay, this one's going to be a little bit tricky, right? Ultimately, the formula here, it's an electron, right? So it's a negative charge, okay? Ultimately, the formula is force equals Q VB. Really, there's a sine theta in there. It doesn't even show up on the IB stuff, okay? But it's QVB. This is the Q and the V. This is our index finger for the cross product. This guy here is our middle finger. This force is going to be our thumb. Okay, it's traveling to the north, so we've got north, south, east, west. Okay, so our let's draw a picture of that. Right, here's an electron. So our current is that way, right? It's to the north. There's a force vertically downward, so the force is like that. There's our force, right? Okay, so I'm doing north is up the page, right? Vertically downward, the x dot would be up, x is down, right? I'm doing map problems here, right? Okay, so let's see, we've got the thumb, so let's see, let's figure out, it says, what is the magnitude direction of the magnetic field exerting this force? So we got to solve this for B. The theta drops out because it's 90 degrees, the angle here, okay? And so, let's see, electron travels vertically downward. Magnetic field, okay, so let's assume that the angle is 90 degrees. It's not clear to me why we do that, but let's just do that. Okay, and then, so we're solving for B, so B is equal to force divided by QV, right? Okay, so the force is 2.1 times 10 to the minus 14th newtons. It's an electron, right? So the charge of an electron is 1.602 times 10 to the minus 19th. I'm not putting a minus sign there because that'll confuse me too much. Although it would work, right? I mean, it actually makes this thing work. Okay, so let's see. It's 3.5 times 10 to the 4th meters per second, right? This is coulombs, right? So let's figure that out first. 2.1 times 10 to the minus 14th divided by 1.602 e to the minus 19th divided by 3.5 e to the 4th. And I get 3.745. Apparently I only have 2 sig figs, Teslas, right? Okay, so that's about 3.7 Teslas, right? And now let's see, how do we figure out the magnetic field? Well, this is going to be my index finger, right? I'm going to put my index finger this way, right? Okay, my thumb is going to be into this page, okay? So I'm doing that, that's my thumb. So index finger up the page, thumb into the page. My middle finger is now pointing to the east, yes? Okay, my middle finger is pointing this way. When I do that, okay, but it's an electron, so it's negative east, right? It's in the negative east direction. And we on the West Coast, we don't like the negative east direction. We like to say west. Okay?